A polynomial is an expression that contains at least one term if there is more than one term using addition and subtraction, where the variable is in the base and the exponent on the variables are whole numbers. So an example of a polynomial, and you've probably seen this before, would look like this. 4x cubed plus 7x squared minus 2x plus 1. All right, so let's talk about the parts of each of these polynomials. Okay, the first part of the polynomial is the variable. The variable of the polynomial is the unknown. So the variable of our polynomial I have written here would be x. And you have multiple x's. We have x to the first, x to the second, x to the third. You can have more than one variable in the polynomial, but most of the time you'll see x as the variable. All right. A term is the second part of a polynomial expression. A term of a polynomial is a number or a variable or the product of a number and a variable in the expression. So we have 4 terms in this polynomial. The 4x cubed is our first term. Then we have 7x squared as a second term. Minus 2x is my third term, and plus 1 would be the last term. Notice that terms of a polynomial will be separated using addition or subtraction. So in our definition of a polynomial, we say a polynomial is an expression containing at least one term, but then using addition and subtraction to separate them. So a polynomial is really an expression that contains multiple terms. The next part of a polynomial involves part of the term, and it's called the coefficient. The coefficient of each term is the constant that's being multiplied by the variable. So on our first term, the coefficient would be 4. On our second term, the coefficient is 7. On our third term, the coefficient would be the 2. And the last term, there's no variable, so 1 is the coefficient, but we also call 1 the constant because there is no variable on it. The degree of a polynomial is the highest power that occurs in the polynomial. So we have x cubed, x squared, this is x to the first, and there is no x, so we just say that's x to the 0. The degree of this polynomial is the highest degree. So the degree of this would be to the third degree, because 3 is the highest power. Now each of the other terms have their own degree, but those are the degrees of the terms. We are asking here for the degree of the entire polynomial, and that is the 3 because it is the highest power. An important concept that involves polynomials is the idea of a term versus a factor. So if I have a polynomial here, 3x to the 6th minus x to the 4th. I have 2 separate terms. The degree of my polynomial is to the 6th because the highest power on this polynomial is to the 6th. The coefficient on my highest power is 3. The coefficient on my x to the 4th is -1. Now, this is a polynomial that has multiple terms. Now, you can take your polynomial and you can rewrite it in factored form, which is a concept we're going to take a look at in the next video, but I would just like to factor this for you, and it would be 3x squared minus 1. Now this is in factored form, so we have x to the 4th times 3x squared minus 1. The important thing to know is when you have a polynomial in its factored form, you can start reducing if you needed to reduce the polynomial. In its term form, meaning you have separate terms, you can't reduce because you need to think of a polynomial as a family that needs to stay together unless it's factored out. So, the terms are being separated using addition or subtracted, but factors have multiplication. All right, we have two expressions here. We have one that's in its factored form and one that's in its term form. Let's look at this right side here first. The tempting thing here is to take this x and say, oh, hey, I can divide that into x squared. But that is not the case, because these polynomials that are created of terms can only cancel out with whole factors that are like factors. You cannot cancel out individual terms of a polynomial. So if you look at the right side here, now I have it factored and I have x plus 3 divided by x plus 3. Now you can cancel out whole factors. It is never okay to cancel out terms of a polynomial if there are multiple terms of each group. And that is actually one of the biggest mistakes I see in math, is trying to cancel out terms where you can actually only cancel out factors.